frequency division multiplexing, there is code division multiplexing. All are different multiplexing techniques we will be studying in the future. So these are all possible only because of modulation. So these are the 5 very important points while why we should modulate the signal or need of modulation. So I'll just summarize. First thing is for traveling over longer distance. So whenever we are modulating the signal, it can travel over longer distance because high frequency can travel for longer distance. Second, if we are modulating the signal and making the overall signal, modulated signal, high frequency, then the effect of noise in the modulated signal is less. So if the effect of noise on the modulated signal is less, means proper reproduction or faithful reproduction of that baseband signal at the receiver side is possible. Third thing, modulation helps reduce the antenna height. So for that only one formula you have to remember, that is antenna height is given by lambda by 4, where lambda is substituted by c by f. So antenna height is given by c by 4f. So if very low frequency signal, definitely we will be finding that, so this f and antenna height and this frequency, they are inversely proportional. So for very low frequency signal, directly if we want to transmit the baseband signal of 300 Hz, the antenna height will be too much unrealistic. We cannot put antenna at that height. So what is the solution? Solution is we have to increase the frequency of the modulating signal without changing the property of the modulating signal. So only modulation process can help with that. So by modulation process, we are keeping the baseband signal intact inside the carrier signal, and the carrier frequency is becoming the frequency of the modulated signal now. So if you are substituting in case of 300 Hz, if you are substituting 3 megahertz, in that case we are finding that the height of the antenna is getting reduced. So this is the third point, very important point, that is modulation helps reduce the antenna height. Fourth point, modulation avoids mixing of signals. So many signals if you want to transmit, if you are modulating the different 4 signals with different 4 carrier frequencies, then even if we are transmitting all those 4 modulated waveforms together, then also at the receiver side, by proper filtering, by proper demodulator, we can segregate first all the carrier signals, and then from the carrier signals we can segregate the 4 different baseband signals. Fifth point is also in line with the fourth point, that is modulation helps multiplexing possible. There are different types of multiplexing, TDM, FDM, CDM. So CDM goes in the domain of digital and TDM, FDM is in the domain of analog. So these are the positive points, or these are the need of modulation. Very important question, very frequently asked in exams, so please prepare. Next point, we will start and we'll see the basics of amplitude modulation. The first primitive type of modulation that was invented is called as amplitude modulation, and initially all the modulation that was taking place worldwide was amplitude modulation. So in our radio also we have found 2 types of channels, one is FM, one is AM. Initially it was there, now everything has become digitized. So initially we used to have a button, small button, we had to change the button from AM to FM. Okay, so if the button was in AM, that means it was receiving all the channels which was being transmitted through amplitude modulation. And for FM, obviously FM was giving more clarity. Okay, so for FM we were receiving all the channels which were modulated in frequency modulated waveform. So like that. So first we will see the basics of amplitude modulation. So what is meant by amplitude modulation? Simple definition here the amplitude of carrier signal is modulated or changed by means of amplitude of baseband signal. And whenever I am saying baseband signal, the same is modulating signal. Okay. So this is a very basic definition of amplitude modulation. Here the amplitude of carrier signal is modulated. So why it is called amplitude modulation? Because the carrier signal amplitude is being changed by means of amplitude of baseband signal. Okay, so if I say that modulating signal, so the notations that I have used here is called as MT, and remember all these signals are AC. Initially we are saying all the signals are AC. Yes, DC also can be transmitted, but for our proof and also there is a small proof, there is a small equation for that. Initially we are taking very simple sinusoidal signals, okay, baseband signal. So this signal is to be transmitted. This is a low frequency signal and given by MT, and this is given as AM cos 2 pi FMT plus pi. So there are three parameters in any sinusoidal signal. One is its peak amplitude, one is its frequency, and third one is phase. So this is a modulating signal, this is a low frequency signal. Next comes the carrier signal. This is given by CT. C stands for carrier. So this is AC cos 2 pi FCT plus phi 1 or phi 2 we can do, okay, like this. Or for ease of operation we ignore the phi first. We are taking that there is no phase in amplitude or in modulating or carrier frequency. Okay, we're taking very simple thing. And very important thing, FM is less because this is modulating frequency. FC is very high because this is C stands for carrier, like this. Okay, this is very high, okay, and FM is very less. In this case, they are mixed by means of amplitude modulation, and they are producing a mixed signal. They are producing a mixed modulated signal given by ST, small st. Okay, how to write that? So what I am saying is this amplitude is being modulated by this whole thing. Okay, so in this case if I am saying ST, just see how to write this equation. So the amplitude part, in this case it was peak was AC. Now this amplitude will become AC plus AM sine 2 pi FMT. That's all. And this cos omega CT part will remain cos 2 pi FCT. Now understand this modulated waveform. So what is the amplitude of this part? So this part is the varying amplitude. This part is the varying amplitude. And what is the frequency of modulated? So frequency of modulated signal is equal to FC. This is same as carrier frequency, like this. So these are the tricks, these are the main things to understand in case of amplitude modulation, that whenever I am mixing these two signals, this amplitude is getting modulated or changed by this whole amplitude. So whenever I am saying modulated signal, this thing is having a time varying amplitude where this modulating baseband signal is present and its actual carrier amplitude AC is getting added with it. Okay, so actually this baseband signal is overriding on the carrier amplitude, but the frequency part of the carrier, that is cos 2 pi FCT, that is remaining constant. Okay, so if I ask what is the amplitude of the modulated signal, so this part is the amplitude part. This part is the amplitude of modulated signal. This part is the amplitude of modulated signal, and this part is the phase or frequency part. So one thing I told you that the phase of or frequency of the modulated waveform will be same as that of carrier waveform. So this is FC, that is also FC. And inside the modulated waveform, I am hiding this modulating signal. Okay. While demodulation, all these things, AC is taken out, this thing is taken out, and this thing is actually extracted and reproduced at the output transducer. Now, final thing, how does this modulated waveform look like? So there is a pictorial view, and there is a very small proof of this. So this is AC